So far we have studied the examples of admittance and the admittance parameters. Today this is about some other example of the admittance parameters, also some applied things, and after that we will also discuss the impedance parameter. So let's take it. So this is an application of the admittance parameter. In this slide we are using some external resistance, that is 4 ohm, and that 4 ohm resistance is used for calculating the current through this resistance. So what we are actually doing, we are using this pi network. So this type of network has parallel paths, so that's why we are using the admittance parameter. If we are having some other type of circuit which we later on discuss, then we will use the impedance parameter or some other things. So first we are using these two equations for calculating our y11, y12, y21 and y22. So we are calculating these things. So for that we are using our same method, that first we are removing this resistance of the output side by making this thing short circuit. So if we make this thing short circuit, these things will be removed, and we will be left with I1 and V1. So y11 would be equal to 1 over 1 divided by 1 over 2. So 1 over 1 plus 1 over 2 is 2 plus 1 by 2, which is 3 by 2 Siemens. So 3 by 2 Siemens is this one. Okay, after this we are short circuiting this side and making this thing open. So what will happen due to that, we will calculate y22 as 1 over 3 plus 1 over 2, and this thing is gone now. So this is 3 plus 2 divided by 6, which is 5 by 6 Siemens. So this thing is y22 is 5 by 6. After this we calculate this y12 or 21. So for that we are using this same circuit which is already built, except we are removing these things from it. Okay, so what we are actually doing now is that we are saying that a part of I2 called I2 dash is our opposite of I1. So I2 dash is flowing here, which is opposite of I1. I1 is not flowing in it because this thing is 0, because this is a better path for it. So that thing can be calculated as the current branch in which the current is not flowing. So 3 divided by 3 plus 2 ohm, which is 3 divided by 5. So we are having 3 by 5 into I2 here, into I2. This thing is negative. So what we will do, we will check some equation here in which we can replace this I2 by V. So here is I2 and here is V1. So if we replace this thing, we are already having this equation, first one, in which we are having I1 and y11 is 3 by 2 and V1. So this is for our V1. For V2 or for I2, we are having I2 is equal to, now this thing here we are having y22 as 5 minus 5 by 6 into V2. So we can replace it with this equation. So we will have minus I1 is equal to 3 by 5 into minus 5 by 6 into V2. So that will become 2 minus 1 by 2 V2, which is I1. So this thing is I1. Let me make this thing yellow. So this is I1 and this is I1 and this is V2 and this is V2. So this thing must be equal to Y12. So we can say that Y12 is equal to minus 1 by 2 of V2, which is here. So similarly you can calculate this other part by using the value of I2 as a branch current of I1 and then putting it in the value. So this is the whole method, and after that let's move towards our next thing, in which we will be using these parameter values and calculating our interest current in it. So we will be calculating I2 here in this branch current. So we are already having I1 equal to 2 ampere here, and V2 is equal to IR. So I2, which is opposite to this current which we are expecting to be I2, so minus I2, it is going from this positive side to this side, that's why it is minus, into R, which is 4. So we can replace these values as I2 is equal to minus V2 by 4 in this equation and this in this equation. After that, this is a bit direct step. It was actually V2 and this thing was actually here minus V2 by 4. So minus V2 by 4 went here and made it plus V2 by 4. So this is the second step. First step, you have to put this value here and this value here. So after putting it, you get all the equation in terms of V1 and V2. Solve it and you will get the value of V2. So V2 is minus I2 into 4, which says that I2 is this value divided by minus and 4. So this is the way you use these parameters to calculate some other stuff. In this example, we are again calculating the admittance parameter. So method will be the same. What was the method? The method was that to make this thing short circuit, make this first side short circuit, and second side short circuit, and then calculate Y11 as 40 1 over 42 plus 1 over 21. So this is 2 plus 1 divided by 42, which is 3 by 42, which is 1 by 14. 14 plus 14 is 28 and plus 14 is, so this is S. Next we can also find Y22 as make this thing short circuit. So Y22 would be equal to 1 over 10.5 plus 1 over 21. So solve that thing and you will get your answer. After that, the important step about this is that we calculate the branch currents in terms of the total current. So for that, let's go to the next slide. So we are already having this thing solved, that we are having on the this thing on the second side, and what we are doing is that we are first saying that I1 minus is a part of I2 called I2 dash. So this thing is equal to the 10 0.5 divided by 10.5 plus 21 multiply by I1 multiply by I2, sorry, and then use the value of I2 from the equation, which is I2 is equal to y1 y21 v1 plus y22 v2. So here you can replace this I2 by v2 because we are already having y12. So I2 is equal to y22 v2. Since this thing was 0, this thing is 0 here. So this will give you the value of I2 in term of v2. So you can put this value here. We are already having this equation in here, that I1 is equal to minus 10.5 divided by 10.5 plus 21 multiplied by I2, and put the value of this I2 like this. So you will get this thing in terms of V2, and these values would be your Y1, this is in terms of, this is I2, so this would be Y12. Okay, so you can also predict it that this is Y12 because we are having I1 and this is I2 V2, so this is Y12. So you can calculate Y12 like this. In this example, we are calculating the admittance parameters and finding the current I0, whereas this I0 is flowing in this branch. Let me mark it here. In this branch, this I0 is flowing. So the first step is to check the circuit structure. So the circuit structure is same as that of Y parameter circuit. So we are good to go. Calculate the Y11, Y12, Y21 and Y22 for this particular circuit. Same method as in previous. So we have calculated it. Let's assume that you have calculated it, and after that what you will do is that you will replace I1 in it and this I2 in it. So how will you replace it? For that you study this circuit, that I1 is 10 ampere. So I1 is 10 ampere, it can directly be replaced. So how to find I2? I2 is actually the current that is flowing same as I0 but in opposite direction. So I2 is equal to minus I0. I0 is going downward, whereas I2 will go upward and to the left, up and to the left, and this thing is going, I0 is going downward. So I0 is negative of the I2. Okay, so this is I2, and this thing is equal to V by R, whereas V is V2. Here it is V2 divided by R is R is 5 ohm. So we can replace these two values, 10 and V2 by R. This thing is I0 and this is V2, same as ours, but this thing is positive and this thing is negative because we have shifted the value. And after that we can see that our I2 is minus I0, so I2 की जगह हमने minus I0 put किया, और same case V2 और V2 की जगह हमने I0 into 5 put here. So 5 I0 is V2, and then solve these two equations and you can get the value of V1 and I0. So we are not interested in V1, we will just calculate I0, which turns out to be this one. So this is the procedure. You just check it and then let me know in the comment के आप लोगों को मुश्किल लगा आसान लगा सही, फिर बाद में अगर कोई मसला हुआ तो डिस्कस कर लेते हैं, बट दिस इज जस्ट पुटिंग वैल्यूज इन इट. You just have to find the parameters 1 1 2 2 2 1 2 2, and then you find the value of your known things, and using these known values you calculate the unknown values. Now coming to the impedance parameters. Impedance parameters, in short, if we want to describe it in one sentence, it is the Ohm law. So it is V is equal to IR. So how will we say that it is Ohm law? We add up the voltages that are dropped on the primary side and the secondary side. Voltages that are dropped on the input side and on the output side. So for that we divide the impedances into two formats. The impedance that is seen on the input side from the current of input and voltage of input side, and the impedance that is seen on the input side from the input voltage of the input voltage and the output current. So we are applying voltage and we are checking the currents. That's why it is an Ohm law application. Okay, so there are two equations. We are considering the current I1 and I2, and we are calculating the voltage that will be developed on the first side. So V is equal to Z11 I1 Z12 I2, the voltage in the first that is causing current in the second, causing current in the first. So this is 1, that's why this thing is 1 and this thing is 1, because V by I is equal to Z, and if this thing is 1, this is 1, so this is 1. If V is 1 and I is 2, this is 1 2. So 1 2 is V1 and I 2. So this is 1 2 impedance. And how will we calculate this thing? For that we will use our method of making these things not working on the second side. So not working means that this equation is depending upon this current. So we will make this current equal to 0 in order to reduce this equation. So if you want to find this 1 1, if you want to find this 1 1, what we will do, we will make this I2 equal to 0. So I2 equal to 0 will give us Z11 V1 by I1. Similarly, it can also give us Z21, because Z21 is from the second equation, such that not this one, sorry, this one, we are making I2 equal to 0. So I2 equal to 0 is this one, and this is from second equation where this thing is 2 V2 and V1. So V2 and V1 I1, and this I2 is 0. How we make I2 0? So this is an interesting question. For any current to be made 0, we make that side open circuit. That means that you do not have to do anything with the circuitry. You just let it open and it will automatically reduce some resistances. It will reduce some impedances. So what things can reduce impedances? For that, the circuit should have something like this, a floating resistance. If we are having a floating resistance and we do not apply some voltage or some current here, this current would automatically become 0. So if this thing is open, what will happen? This current will be 0. So if current is 0, there is no drop in this branch. So a floating resistance is required in this discussion, means that a floating resistance is required. So how will we say that we are having a floating resistance? So that comes to the point that there are some circuits such as T circuit. T circuit is the circuit that we are talking about here, in which we are having some floating resistance. So before this, we were having the pi circuits. Pi circuit had no floating resistance. Instead, they were having a network like this. So if we make this thing open, there is no effect on this circuit. But if we make this thing short, then there is an effect of reducing this resistance. So how will we reduce resistance in this circuit? By letting this branch or this branch open. So that is the scenario here. Let's do an example on it in order to enable us more known to this scenario. So this is the circuit which I was talking about. In this circuit, we are having this impedance parameter calculation, and we are having the T circuit. T circuit means that if we let this thing open, what will happen? This resistance would be neglected. So we are having these two equations, this one and this one. And what we are doing is that we are making I2 equal to 0, which will cause these equations to reduce to only this part. So for I2 equal to 0, what we will do is that we will just let this I2 side open. So if we make this thing open and see this circuit from this side, what will we see? We will see that its resistance or impedance Z will be equal to 2 plus minus 4J. So this impedance would be termed as 1-1 impedance, because this side is not calculating it. Similarly, if we check the circuit from this side, I will remove this thing. So now what we see is that this impedance is not calculated. So the total impedance is now Z22, and Z22 is J2 minus 4J. Only this and this. Previously it was this and this, now it is this and this. So this turns out to be minus 2J ohm. So this is how we calculate this 1-1 and 2-2. Its second part is very much easy. The 1-2 and the 2-1 part. Why it is easy? Because we know that if a current is not flowing in a circuit, then its any point is having the same voltage. So let's say let's clean this thing. This is a very interesting phenomenon, and you might have understood it from the way I talked about it, that if we are having, let's say, a resistance network like this, and here we are having some resistance, and here we have some source voltage V. So if we check the voltage here, it is V, and let's say this is R and this is R. If we check the voltage here, this voltage depends upon this voltage Vx and this voltage. Now on this point, if we say that there is no current in it, I is 0, So if I is 0, V is equal to IR. So drop is 0, drop is 0, drop is 0. So no drop. That means that this voltage is only flowing on this side for its current, and there is no drop on the left side. So we can say that this voltage which is available here is also available here, and this voltage will be same as the voltage drop in these two resistances. So this is V and this is 0 and this is R and this is R. So this is V by 2 and this is 0. V by 2, 0. So this voltage here is V by 2 as well. So if this voltage is V by 2 and this voltage is V by 2, so will the current flow in it? No. So I is 0, that's why. So this is the scenario in this circuit which we are talking about. It is for the fact that the circuit is open from one side. So when the circuit is open from one side, let's say this is our circuit, we want to study it from this side and this side is open. So if this side is open and we want to check the impedance of this circuit from this side, so here this would be the input impedance 1, 1, which will be equal to 2 minus 4j. Now if we check the impedance from this side, that is 1, 2. So 1, 2 would be equal to this. Resistance will not affect anything, only this is having some voltage across. So this voltage is here, V2 is here. So Y12 is minus 4j. Similarly, Y21 would be also equal to minus 4j because the same case would repeat from the other side. So that's why we can see that this thing and this thing are same. So the summary of this part is that the 1, 1 and 2, 2 will be calculated from this branch and this branch, and the 2, 1 and 1, 2 is only calculated in the center branch. So this resistance is 2, 2, this resistance is 1, 1, and this is 1, 2 and 2, 1. So this is the calculation of these resistances. So this is easier than that one, the admittance, but it is easier because the circuit structure is different. Now let's calculate the value of current in 4 ohm resistance using these parameters that we have studied. So for that we are having these two equations, this equation and this equation. So we are having this V1, put this V1 in here, and we are having this thing on the V2. So V2 is equal to minus I2 into 4. Why minus I2? Because V2, the current is going away from the source, not into the resistance but outside the resistance. So put this V2 as I2 4 minus and V1 as 12 volt in these equations, and then we will be left only with I1 and I2. Solve for I2 only. So if you solve it for I2 and then multiply this 4 ohm with that I2, that would be the voltage across this resistance, and if we just find I2, that is our answer. So just check this question and explore it. The solution is quite simple. In this circuit, we are again calculating the impedance parameter and the 4 ohm load current with a 24 volt. So how will we find the impedance parameter? Let's just quickly find it. So Z11 is 12 plus 6, Z22 is 3 plus 6, Z12 is 6, Z21 is 6. So we have calculated it pretty much easy. Okay, after that we are having 4 ohm resistance in which we want to find the current. So put this this 4 ohm in terms of voltage, and it will be like V2 is equal to 4 V is equal to IR. So 4 multiplied by I2 multiplied by a minus sign. So this is the first thing that we will be replacing in this equation, and not in this equation, the equation where V1 is equal to Z11, V is equal to IR. So I1 plus Z12 I2, V2 is equal to Z21 I1 plus Z22 I2. So put this V2 in here, and V1 की जगह हम क्या put करेंगे? V1 is equal to 24, and if you solve these two equations, you would get this I2 into minus 3 is something that you will have to solve it by making these things equal to one another. So this is a whole multiplication of the equation. It is not something that is concerned with the individual values. So just try it and you will know the value of I2, and that is it. This is how we use these parameters. So this one is easier than the previous one just because this circuit is simpler for impedance. अगर हम इसी circuit को admittance से करेंगे then you will know इसमें एक resistance जो है वो extra बन जाएगा, because admittance में क्या होगा? Admittance में you will make this thing short, and by making this thing short, these three has to be considered now. So this is the difference. Just remember this thing and we will use it in the future. Thank you.